All right, let's dive into this 5-mark GCSE math question. I'm going to walk you through it step by step, so you know exactly how to nail every single mark. And we'll be using the official mark scheme as our guide, so you can see what the examiners really want.
Okay, so here's how we're going to tackle this. We'll look at the challenge, figure out the frequency density, draw the perfect histogram, handle the estimation, and then work out the final fraction. And of course, we'll check it all against the official mark scheme.
Right, let's get started. First up, unpacking the question itself. So, here's the challenge. Question 13 from the 2024 Higher Paper 1. We've got a table here showing how long 150 people were in a shop. The task? First, draw a histogram, and then use that histogram to make an estimate. Pretty standard stuff. But the devil is in the detail.
Now, the first thing you absolutely have to notice is this little symbol right here. This is a non-calculator paper. That's a huge clue. It means all your working has to be super clear and methodical. No hiding behind a calculator on this one.
And what are we playing for? 5 marks. Now that might not sound like a lot, but 5 marks can easily be the difference between one grade and the next. This is a big deal. Okay, so before we can even pick up a pencil to draw this thing, there's a crucial calculation we need to do. The question gives us a table, but something's missing. Something we have to figure out first. And that missing piece is frequency density. This is so important. On a histogram, the height of the bars isn't frequency, it's frequency density. And how do we find it? With this simple formula, frequency divided by class width. You've got to know this. So let's put that formula to work. For that first row, we've got a frequency of 20 and a class width of 10. So 20 divided by 10, that gives us a frequency density of 2. Simple. And we just do that all the way down the table. Adding these extra columns and showing this work, that's exactly what an examiner wants to see. It's your first mark in the bag, right there.
All right, now that we've got our numbers crunched, we're ready for the fun part, actually drawing the histogram and visualizing this data.
Okay, we start with a blank grid. The horizontal axis, that's our time. And the vertical axis, crucially, that's our frequency density. Don't just label it frequency, that's a classic mistake. And now we just start drawing our bars using our table as the guide. The first bar goes from 0 to 10 with a height of 2.0. Done. The next one goes from 10 to 30, so it's wider, with a height of 3.5. You just build it up, bar by bar. Get at least 3 of these right, and boom, that's another method mark secured. Okay, histogram's done. That's part A sorted. Now let's tackle part B, which is where we have to actually use this graph we've just drawn. So, the question asks for a fraction of the 150 people. Okay, so we know our answer is going to be something over 150. The real work is finding the top number, the estimate for how many people were in the shop for between 20 and 40 minutes.
So, how do we get that number from our graph? Well, remember, in a histogram, the frequency is the area of the bar. So we need to find the total area between the 20 and 40-minute marks. Let's walk through it.
Okay, if you look at our histogram, the 20 to 40-minute range is a bit tricky. It slices across 3 different bars. First, we need the bit from 20 to 30 minutes. That's a 10-minute slice of our second bar. The height is 3.5. So 10 times 3.5 gives us 35 people. Next, we've got the whole third bar, from 30 to 35 minutes. We already know the frequency for that one, it's 22. Easy. Finally, we need the section from 35 to 40 minutes. That's a 5-minute slice of the fourth bar, which has a height of 2.0. So 5 times 2 is 10. Now we just add them all up, 35 plus 22 plus 10. That gives us 67 people.
And that's our top number. So the final fraction is 67 over 150. Job done for part B.
Okay, we've got our answers and we're feeling good. But let's look at this through the eyes of an examiner. We're going to check our work against the official mark scheme to see exactly how those 5 marks are handed out. See, it breaks down perfectly. That first M1 method mark, that's for calculating the frequency densities. The second M1, for drawing at least 3 bars correctly. Then you get an A1 accuracy mark for the whole histogram being spot on. For part B, there's an M1 for showing the method, the adding up of the areas, and finally the A1 for getting the answer, 67 over 150. We've hit every single point.
So the mark scheme says 67 over 150 is the answer. Great. But then there's this little note, or FT, their histogram. What on earth does FT mean? This is super important.
It stands for follow-through, and honestly, it's your best friend in an exam. It's a safety net. It means even if you messed up your histogram in part A, Say you made a small calculation error, you can still get full marks for Part B as long as you use your incorrect histogram correctly. The examiner will follow your method and mark it based on your own earlier mistake. How good is that?
So this brings us to a really important point. What's actually more valuable in an exam? Getting the final number perfectly right, or proving without a doubt that you understand the method? This question shows that showing you're working, proving your method at every single stage, that is the key to unlocking the marks, even if you slip up along the way.